No, like if I ask you what is a solution to a system, what would you tell me?
Oh, where the points connect.
There you go, where the lines intersect. So let me write this down here. Not so much classifying solutions, but identifying a solution. A solution for a system is the point of intersection. So this leads me to three things. There are three types of solutions. Three. I'm sure you probably know what they are. I'm gonna kind of try to squeeze mine right here. The three types of solutions. Give me one. No solution. Thank you. We write that with that little symbol right there.
Infinite.
Okay, hold on. One solution looks like what?
It's like
What does one solution look like?
It's just like two X's that do that. Or like that, and they meet.
No, I mean like you write it like an order pair. Sorry, I think I didn't ask that correctly. My bad. So then the other one was what?
infinite many.
Infinite, which is that little infinity thing. Or you can write it as all real numbers. I'll take either one of that. So those are my three types. What we're looking at today with this assignment is what does a solution look like when it's graphed based on these three types, and when it's solved algebraically based on these three types. Because obviously when you're looking at a graph, no solution means the lines will not cross. What would it look like if it was one solution? What would the lines do?
They would intersect.
They would intersect at some place. If you have infinite solutions, what would the graph look like?
It would
They would
just
be
be
on
a
one
straight
line.
line and then another one on top.
They overlap. So like, don't write this down, but this is just a reminder, because we did this in our notes. If you have one solution, you're just gonna have some place where the lines intersect. That's one solution. If you have no solution, then that means your lines are going to be parallel. There you go. They will never intersect. If you have infinite solutions, that means that your lines will be the exact same thing. So it will look like it's overlapping. That's kind of sloppy. But yeah, this is one solution. This is no solution. And this is infinite solutions. When you are solving it algebraically, you're not looking at a graph. You're looking at the values and asking yourself, what do these values mean? So there will be times when you will clear out, get an x equals, and you'll get a y equals. That's when you have one solution. If you do not get x equals or y equals, then that means it's going to have to be one of the special solutions. So you look at what's left, and then you ask yourself algebraically, what does this mean? For example, if I were to get, write this on this board, my x's and y's cancel out, and I get this, or I get this. What does that mean? Okay, you said no solution? Why?
Because 4 doesn't equal 6.
Perfect. What would this mean?
Infinite.
Thank you. It's infinite. So like knowing what you see algebraically is essential for like doing these problems, because I'm gonna have you do them both ways. So first, look at your systems here. We're going to solve by graphing. To solve by graphing, what do you have to do? Thank you. Isolate the y. Put it in slope-intercept form. This is the scratch work right here. You can put all the scratch work in the little spot. But show me how you isolate it. Didn't do any talking on that, but let me tell you what I did. On the first one, I first subtracted my 2x and then divided by the 3. Simplify this. You have to simplify it. And you're going to get, I'm putting the x first, y'all. Negative 2 over 3x plus 3. This is what I got for the first one. This is in slope-intercept form. For the second one, I added the negative 4x, but then I divided by a negative 6. Look at the sign in front of this, a negative 6. When I simplify this side, it becomes y equals, and notice what happens to 4/6. It becomes 2/3. Well, negative to be exact. And a -18 and a -6 divided is a +3. What do you notice about my two equations?
They're the same.
When your two equations are the exact same, what does that mean?
Infinite.
There we go. Because these are the exact same, that means that you're going to have infinite solutions, which is the same thing as all real numbers, which is the same thing as negative infinity to positive infinity. However you want to look at it, that's going to be what happens. So then, if it's the same, what am I going to be doing here?
Drawing a line that's gonna both overlap.
There you go. We just draw it one time though, because it's the same thing. So graph your equations by just graphing that one line. Go up 3, and your slope is -2/3, so we know that means down 2 and then to the right 3. Repeat that and then go in the opposite directions as well. That is not bad at all for me. That's what's up. There's not that much space here. I'm gonna have to write it really small because the next thing we're asked to do is to algebraically solve it. Now, yeah, we already know the answer is going to be infinite. We know this, but algebraically you need to see what it looks like. So take the equations that I circled up here, copy it right here, and then pick a method to solve. What method do you think will be easiest? Thank you for saying that. I was in my mind saying, please pick elimination. Please pick elimination because it is the easier method. I'm just copying my problems down so that I won't have to write up there. It's like kind of sloppy. I'll zoom in. Give me just a second. Elimination is the method I would prefer as well. Remember, the goal of elimination is to get rid of a variable. So to get rid of a variable, you need to be the exact same number, but the signs need to be opposite. You all know what we want to do here. Get rid of the x or the y. Which one?
X.
The x. Then if I get rid of the x, what am I multiplying by?
2.
This entire top will be multiplied by 2. That way, it will turn this number into a positive 4x, which we know will cancel with the negative 4x underneath it. When I distribute, since I don't have that much space right here, I'm going to take my answer for this and put it underneath here. So 2 times 2x gives me a 4x. That's where I'm going to write it. 2 times the 3x gives me a positive 6x. And then 2 times that 9 gives me positive 18. So this here is what I now have to solve. When you solve it, what do you see happen?
It's 0.
They all cancel each other.
Everything cancels out. Everything. You have nothing here. You have nothing here. The biggest mistake people say is when they look at this, they say no solution. When they see nothing, they say no solution. But if you have nothing on both sides, this means that you have a true statement. Because 0 equals 0, doesn't it? If your statement is true, then that means it is infinite solutions. There we go. I'm writing it more than one way. And I want to talk to you about the lines and the types of solutions next. Let me know when you're ready.
Ready.
Okay, so first, what do you notice about the lines, y'all? This is not a trick question.
They're the same.
There you
They're
go.
the same.
They're the same.
Thank you. They are the same. Or if you said that they overlap, that's fine. All right. What is the solution?
Infinite
Infinite.
many.
Infinitely many. All real numbers. I'm going to say infinitely many. Where do they intersect? Where do the lines intersect? Everywhere, all over. All over or everywhere. Either one. And how many? Once again, infinitely many. This is something new. We haven't talked about consistent and inconsistent or dependent or independent. So let me just tell you right quick. On the top of the page, I have it typed out so you can refer to this. And it's kind of small, but the first part says, if a system, has at least one solution, is consistent. If it has no solution, it's inconsistent. So let's come down here. Is it consistent or inconsistent? It's consistent. And then we'll go back to dependent, but write this down. It's consistent. Again, it's consistent because it has at least one solution. Now, to determine if it's dependent or independent, then look at it like this. If it has one solution, it's independent. But if it has infinite, it's dependent. Because think about that. Infinite means their solutions depend on each other. Because it's the same line. So the solutions depend on each other if it's infinite. Because you see it's one line, right? So the answers are all dependent on the other answers. So this would be consistent and dependent. Do you have a question? Because I'm not doing all of it with you, but I will start you on number 2. So this is what you're going to do. You're going to finish the rest of number 2 and number 3 all on your own before you turn it in.
Wait, how'd you get independent and dependent?
Okay. Independent is when you have exactly one solution, it's independent. If you have infinite solutions, it's dependent.
Okay.
Infinite is dependent.
I didn't see that illustrated.
Yeah, it's kind of small. Really, very small. If I didn't put it there, I would have put it there. But I did put
Looks
it there.
like this.
Because if I would have noticed that, or no, I wouldn't have answered the question.
Yeah.
I think it's teeth in there. I don't know.
Alright, so once more, graphically requires that you put it in slope-intercept form. Algebraically means that you're going to use either elimination or substitution. Your choice. One last time, I'm showing you how to do this because when you do your next assignments, when you're plotting, they'll be like, okay, remind me again, how do I set this up that way? Always get the y by itself. So you move the x over. When you do so, you change the sign. Always divide by what's touching the y. So if there's a sign that's negative, it's a -2. Always remember whatever the sign is. So I'm going to come down here and change it. So that way it's not too sloppy. When I subtract my x, I end up with a -2 having to be divided. It's kind of sloppy. Let me see if I can make that neater. So I'm subtracting my x, and now divide by -2. So my y will equal, I want to put the x first. How am I going to write -x over -2?
1/2 and then
Yeah.
1/2 x.
1/2 x, thank you. -4, thank you. This is my new slope-intercept form. Now, the other one right here, 3x minus 6y is 6. Again, I need to move the x over, so I'm subtracting 3x. But then I'm dividing by -6.
So would it be no solution?
Why would you say that?
Because the
They don't
x's,
What do you
the
have to-
same slope but different wires.
Now, you jumped ahead, but I want to make sure you understand what she said was correct. These would simplify. So the -3 over -6 would give me a 1/2 x. And then 6 divided by -6 is -1. What she said was she felt it would be no solution because they have the same slope. but their y intercepts are different. She's right. Because if you have different y intercepts, but the slopes are the exact same, they're never going to catch each other, so to speak. They're never going to cross. Don't believe me, graph it. So let me graph the first one. Go down -4. 1, 2, 3, 4. And then up 1/2. Best as I can. Draw this line. Yeah, that's pretty bad. And the other one. And yep, that's what the graph looks like when there's no solution. But algebraically, pick your option of what you want to do. Do you want to do elimination or substitution?
I'm doing elimination. Wait, do we get to work it on?
You get to pick whatever method you want. So look, what I want to say right quick before you finish solving this, can you answer the discussion questions for me? I want to make sure y'all got these right before you do the last one on your own. Jump down to where it says what you notice about the lines. What do you notice?
They don't intersect.
They do not intersect. I heard somebody say they are parallel. I'm gonna write that. I hope I spelled parallel right. That's right. So there are 3 things here. It's asking. Number 1, what is the solution?
No solution.
Here we go. Where do they intersect?
They don't.
They don't.
And how many exist? 0. None. So if there is no solution, you might want to flip back. Does it mean it's consistent or inconsistent?
Inconsistent.
Do the lines touch each other? So would they depend on each other then? No. So they're independent. Because if they're not touching, they don't depend on each other at all. So this is gonna make me look in here. So it is, they are independent for this. I only jumped ahead to this because when you do number 3 on your own, I want you to be able to answer the discussion questions. But y'all, make sure you go back and you actually do the work for this here. I'm not gonna do it for you. Do the work for this. See if you can understand why the answer comes out to be whatever it is. If you have questions, you can ask me, I can help you. But when you're done, you're gonna turn this in to the folder.